students, chemistry students, you are welcome to today's class. Today we are going to be looking at the IUPAC nomenclature in chemistry. The IUPAC simply means the International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Nomenclature means naming. So you can equally say these are the group of scientists or the group of chemists. Their duty is what? To name compound and to also name elements. If you see an element, if you see a compound like this, you'll be wondering what is the name of this compound. So IUPAC is telling you that this compound is what? Calcium, because Ca is representing calcium, C is for carbon, O is oxygen. So this compound here is what? Calcium trioxocarbonate 4. If it's 2, is calcium trioxo. If it's 2, is calcium dioxocarbonate 4. If it's 4 is tetra. If it's 5 is penta. If it's 6 is hexa. 7 and so on and so forth. But my interest here is I want you to know the reason why this thing is carbonate 4. Why is carbonate 4 and not carbonate 5? So if you also want to know how compounds are being named in chemistry, you should be conversant with your oxidation number. The oxidation number. So it tells you, the oxidation number tells you that the oxidation number of carbon here will now tell you whether it's carbonate 4 or carbonate 2. So let's take a look at how oxidation number is being determined. Number one, if you want to determine the oxidation number of any element in a free state, oxidation number of any element in a free state is what? Is 0. For instance, Cl, chlorine, the oxidation number of chlorine in a free state is 0. The oxidation number of oxygen in a free state is still 0. Whichever element, the oxidation number of the element in a free state is 0. So, secondly, is the oxidation number of any ion, a simple ion. Any ion is what? Is the charge on that ion. Is the charge on that ion. We have like aluminium, Al3 plus. We have magnesium, Mg2 plus. So what they are telling you here now is that the oxidation number of aluminium is 3 and the oxidation number of magnesium is what? Is 2. Because the second rule says that the oxidation number of a simple ion is the charge on the ion. So the third one is that the oxidation number of an element, oxidation number of an the oxidation number of the summation of the oxidation number of a compound is equal to 0. The oxidation number, let me say CaCO3, the oxidation number of calcium trisulcarbonate 4 is equals to 0. So these are the 3 rules guiding the determination of the oxidation number. So let's put it into practical use. Let's check for the oxidation number of carbon in calcium trisulcarbonate 4. I want to know why it's carbonate 4. The oxidation number of calcium, if you want to know the oxidation number of calcium, calcium is what? The 20th element in the periodic table. So calcium is the 20th element in the periodic table. That is Ca2 plus. Ca2 plus means that the calcium can easily lose 2 electrons in its outermost shell and still maintain a normal shape. So let's just look at the I'm digressing, but I have to explain it very well. Let us look at the the electrons in an orbital. So that you see what calcium is. The electron, we have the KLM orbital. KLM orbital. So my interest here is just not the KL or whatever. My interest here is to show you how electrons are being organized in what? In an orbital. We have, and the K shell contains the maximum of 2 electrons. The L shell, M shell, and so forth will contain the maximum of 8 electrons. So calcium is what? Is 20 in the periodic table. Is 20. So we have 1, 2. The innermost part, the K shell can only contain 2 electrons. 2, 3, 4, 5, 6, 7, 8, 9, 10. Are we there? 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's remaining 2 electrons to complete 20. So this is 2 electrons to complete 20. That is why you see Ca2 plus. Means that these two, the calcium can easily lose 2 electrons in its outermost shell. You understand? To maintain an octet structure. So are we there? Coming back to the IUPAC nomenclature of calcium triazocarbonate 4, if you want to determine it, so having known that Ca2 plus, this 2 plus is what the oxidation number of calcium. So we now see the oxidation number of calcium is what? The oxidation number of calcium is 2 plus the oxidation number of carbon. We don't know it. So we want to know whether it's carbonate 4 or carbonate 5. We call it X. So the oxidation number of oxygen, like you know that the oxidation number of calcium is plus 2. The oxidation number of oxygen is minus 2, except the peroxide where they are minus 1. See, oxygen is what? Is 8. What in the periodic table? 1, 2, 3, 4, 5, 6, 7, 8. Are we there? Remember that the LMN orbitals will contain the maximum of 8 electrons. Are we there? So, but if you see oxygen is 8 in the periodic table, it means that after having filled this innermost and the outermost shell, is remaining two electrons to maintain an octet structure to complete it 8. That's why you now see that oxygen is O2 minus. Are we there? It means that oxygen needs the maximum of 2 electrons to maintain an octet structure. Are we there? So that is why it's O2 minus. Coming here now, the oxidation number of oxygen is what? Is minus 2. That is minus 2 times, we already have 3 here, minus 2 times 3. But remember that the oxidation number of a compound, the summation of the oxidation number of a compound is equals to 0. So that means this is equals to 0. 2 plus x plus minus 2 times 3 will give you minus 6 is equals 0. We have 2 plus x minus 6 is equals 0. Are we there? So we collect like terms. X is equals to 6 coming to the other side, we give a positive 6. 2 coming over to the other side, we change to minus 2. So that is x equals to 6 minus 3 is what? Is plus 4. This means that what? The oxidation number of carbon in calcium triazocarbonate is what? 4. That is why you name this compound what? Calcium triazocarbonate 4. Are we there? Calcium triazocarbonate 4. Thank you.